Then now we're going to consider the next part, because what we're trying to answer question C, which had asked us to prepare a payoff table. Then now section D gives us the following. It says it has now been estimated that the probability of the weather conditions are 30%, 50%, and 20% for severe, normal, and mild weather respectively. Then calculate the profit that will be earned if the decision about the production quantity was based on the expected value of demand. In this question, what we need then to do, number one, is to determine what will be the expected value of demand given the probabilities. Are you guys with me? Given the probabilities, what will be the expected value of demand? Then when we're talking about the expected value of demand, we know that we were given three options. You were given what? Severe, you were given normal, and you were given mild. Now they're saying to you, there is a probability of 30% that the weather condition will be severe. And if the weather condition is severe, we expect the demand to be 72,000. That's what we are given in the question. And they say to us, there is a 50% probability that the weather will be normal. And if the weather is normal, what will be the demand? The demand will be 54,000. Lastly, there is a 20% probability that the weather will be mild. And if the weather is mild, the expected demand is 38,000. Therefore now you're going to calculate, okay, the expected value. And we know what the expected value is. It is the sum of all the possible outcomes multiplied by their probabilities. Therefore now there's a 30% multiplied by 72,000. Therefore now that will give you 21,600 units. There's a 50% probability that the demand will be 54,000. For that will be 27,000. Now there's a 20% probability that the demand will be 38,000. Therefore that is what? 7,600. For if you add all of these, therefore the expected demand is 56,200. That's how we calculate. We're saying the expected demand is 56,200. But that's not all we've been asked to do. What have we been asked to do? They said to us, calculate the profit that will be earned if the decision about the production quantity was based on the expected value of demand. Which means if you know the expected value of demand is going to be 56,200, what will be your production decision? Remember we said you can either produce 40,000 units, 60,000 units, or 80,000. Your expected demand is 56,000. Therefore, you're going to choose how many units to produce? 60,000 units. Therefore, the best thing to do is to say, if I produce 60,000 and the demand is expected to be 56,200, therefore, you're going to sit with 3,800 of grit that you'll need to dispose. And we know that the grit that you'll need to dispose, it will be disposed at what total cost? At 90. Because it is the 20 to dispose the grit plus the cost associated with making the grit of 70. Therefore 3,800 multiplied by $90. Therefore how much are we going to get? 3.8 multiplied by 90. We're going to make a loss of 342,000 from disposing this grid. However, the profit will be of what you would have sold. It will be 56,200 multiplied by $80. And the $80 is calculated from the 150 minus the 70. Therefore, 80 times 56,200. Therefore, what is your profit? It is 4.496 thousand. The net now profit that we're going to make is the 4496 minus the 342, which is 4,154,000. That's how you're going to calculate the profit. The last question says, describe the attitude to risk of a decision maker who makes decision using the expected value decision rule. Okay, this one we're just not going to answer now because we have not necessarily looked at the different attitudes that decision maker can have. Once we've looked at the attitudes, we'll then come back to the very same question to answer it. Now, talking about decision-making criteria and risk attitudes. Therefore, we're saying there are three types of decision makers we're going to have as an organization. Number one, we're going to have somebody who's a risk seeker, somebody who doesn't mind assuming a certain amount of risk. And these are the people that are looking for the highest outcome. They're looking for the highest return. Therefore, if they are classified as risk seeker, then they're going to take the highest amount of risk so that they can obviously maximize their return. A risk seeker is somebody who's going to take the highest amount of risk in order to maximize his or her return. Therefore, the other term we can use to describe a risk seeker is the term of a maximax. Therefore, when you're talking about a maximax, we're saying he wants to do what? He's looking for the best possible outcome out of the best available outcomes. Therefore, this is the person that we say he's looking for the best of the best outcome. I'll give you an example. Let's then assume that we want to open a branch of IMAS in Witbank, in Nelspruit, and we're considering opening another one in Pietermaritzburg. Then we're saying there's a 20% probability that we'll have 100 students in Witbank. But there's a 20% probability that we'll have 80 students in Nelspruit. And there's a 20% probability that in Pietermaritzburg we'll have 60 students. Okay? On the same side, there's a 50% probability that in Witbank we'll have 150. And then here we'll have 120. And then 160 here. And then there's a 30% probability that here we'll have 180 students. But here we'll have 200. And then here we'll have 170. If somebody is classified as a risk seeker or a maximax, he is looking for the best of the best. Then now the question that we need to answer, on these three options, which are the best? In Witbank, the best option is 180. In Nelspruit, the best option is 200. In Pietermaritzburg, the best option is 170. He's going to look at the best of the best, which means a risk seeker will be targeting Nelspruit because it's likely to give him 200 students. That is the best out of the three best options available to a risk seeker. Are you guys with me? Good. Then the second guy is known as risk averse. This is the guy who doesn't want to assume a huge amount of risk. he is looking for a guaranteed outcome without assuming any amount of risk. What is the guaranteed outcome? Therefore, if you go now and you look in your slides, we're saying this risk-averse guy, he's also going to be known as a maximin. He wants to maximize the minimum outcome without actually assuming any amount of risk. Therefore, he's looking for the worst possible outcome. He chooses the best of the worst. Coming back to this example that we gave you, Witbank, Nelspruit, and Pietermaritzburg, what is the worst outcome? The worst outcome is that in Pietermaritzburg we'll have a 60, in Nelspruit we'll have 80, and in Witbank we'll have 100. He wants to choose the best of the worst, which means he's going to choose Witbank, which is the 100 out of the 80 and 60, because he wants to maximize his worst outcome. I hope you guys are clear. The last person or the last attitude that we need to consider then, it's an attitude of somebody who will actually say, I understand that they are the best outcomes and they are the worst outcomes that are possible, but I'm going to take the weighted average of all the possible outcomes. And that particular person is the person who is risk neutral, because he's hoping that the worst will be offset by the best and to get him the average, and the vice versa is true. Therefore, this is the guy then who will utilize the expected value. Therefore, the risk neutral guy is the guy that in the previous question we're being asked about. If you go back then to the previous question, they said describe the attitude to risk of a decision maker who makes decisions using the expected value decision rule. Therefore, we're saying that is the person who is risk neutral. Therefore, we've answered the question. Therefore, the expected value person is known as a risk neutral. He chooses the highest expected value. Therefore, now if we come back to this example of ours, then we say let's find a different color. If then now we come back here on the Witbank scenario, we're saying what will be the expected value in Witbank? Then in Witbank, your expected value is going to be 100 multiplied by 20% is going to give us 20. 50% multiplied by 150 is going to give us 75. 180 multiplied by 30 is going to give us 54. Therefore, your expected value is 54 plus 75 plus 20. Therefore, the expected value is 149. Then in Nelspruit, 80 students multiplied by 20%. That is 16. Then 120 multiplied by 50% probability, that's going to be 60. 200 multiplied by 30%, how much you're going to get? It's 60. Okay? Therefore, that's 120, 176. In Witbank, in Nelspruit, the expected value is going to be 176 versus Witbank, which has an expected value of 149. Now we go calculate Pietermaritzburg. Therefore, we're saying there's a 20% probability that we may have 60 students. Therefore, that's going to give us 12. Then there's a 50% probability that we're going to have 160 students. Therefore, that's going to give us what? 80. And then there's a 30% probability that we'll have 170 students. That will give us 51. Therefore, we add 51 plus 80 plus 12. That gives us 143. Therefore, of the three expected value then, in Witbank 149, in Nelspruit 176, in Pietermaritzburg we will have 143 students. Therefore, what are we saying then? The risk neutral person will choose the highest expected value, which means he's going to choose 176. That's what we are saying. That's very important to understand that part. Okay? Now we've got to consider perfect and imperfect information. What exactly are we saying here? We are saying there will be value for having information. We're saying somebody who has information will tend to make the correct decision, whereas somebody who doesn't have information will heavily rely on imperfect information. Therefore, if we want to calculate the value of information, then we say we must calculate the expected profit with information minus the expected profit without information. Are you guys with me? Therefore, that's very important to know how to calculate the value of information. It is the residual between the expected profit with information and the expected profit without information. And this is best illustrated by looking at an example. The example that we're going to be looking at now, it's also another previous exam question paper. This question was asked in September 2013 in a CIMA exam. Therefore, what did they say to you? They said, if you read the required, they said, calculate the maximum amount that should be paid for the information from the market research company. Then let's go through the scenario. They're saying a company has to decide which of 3 mutual exclusive projects to undertake. The directors believe that success of the project will depend on consumer reaction. There is a 25% chance that consumer reaction will be strong, a 40% chance that that consumer reaction will be good, and a 35% that consumer reaction will be weak. The company uses expected value to make this type of decision. The net present value for each of the possible outcome is expected. Now, what are we saying? If we have imperfect information, we are going to rely on the expected value of each of this project. We will choose the project that will give us the highest expected value. Therefore, the first thing then that we need to do is to calculate which of this project are we going to choose based on expected value. Therefore, project A will have the following expected value. How are you going to do it? If the demand, the consumer reaction is strong, we said the probability will be how much? It will be 25%. So we'll say 25%, okay, multiplied by the demand of 1,000 for A. And there's also a 40% probability that the demand will be 250. Lastly, there's a 35% probability that the demand or the consumer reaction will be 200. Therefore, we calculate our expected value. Therefore, how do we do that? Then here we're going to have 250. Then here it's going to be 100. And then here it's going to be 70. Therefore 70 plus 100 plus 250. Your expected value here is 420. Then for project B, we know the probabilities will remain the same. Therefore there's a 25% probability that we're going to, the consumer reaction will be 1,600, that is 400. Okay, we got 400 by taking 25% multiplied by 1.6, and then 40% multiplied by 300, that is 120, and then 140 multiplied by 35%, that is 49. Therefore, your expected value for this project B will be 49 plus 120 plus 400. So that is 569. For project C, okay? For project C, now what is it that we need to do? We need to take the very same probability and apply to the possible outcome. Therefore, there's a 25% probability that consumer reaction will be 1,200. So that will be 300. There's also a 40% probability that consumer reaction will be 375. That is 150. And then there's a 35% reaction, a probability that the reaction will be 100. That is 35. Therefore, you add all of them to calculate your expected value. 35 plus 150 plus 300. Therefore, the expected value is 485. Therefore, which project will you undertake if you have imperfect information? You will undertake project B because it gives you the highest expected value. Now, this is the expected value for imperfect information. The profit that you are likely to make will be 569 when you have imperfect information. However, if you had perfect information, we're saying if you knew beyond reasonable doubt that there was going to be strong probability or there was going to be strong reaction, therefore you would have chosen project B, which gives you 1,600. Therefore you go 0.75 multiplied by 1,600, which will give you 400. But if you knew that the reaction was not going to be strong but was going to be good, which means there's a 40% probability, which project you would have chosen? You would have chosen project C. Okay, project C then will be 40% multiplied by your 375. Then it should give you how much? 150. But if you knew that the reaction was going to be weak, which means there's a probability of 35, then you would have chosen which project? You would have chosen project A. Okay, therefore you are going to have what? 70. 35 multiplied by 200, that is 70. Therefore you sum all of this. Therefore what you have? 400 plus 150 plus 70. That now gives you 620. If you have perfect information, you would have made 620 versus 569 when you have imperfect information. Therefore, the difference between the 620 and the 569 is 51. That will be then the maximum amount that you should be able to pay to gain perfect information. That's how we calculate the value of information. As I was saying, what you are expected to know is to interpret, okay, the decision tree, not to know how to draw it. But the very important thing is to know how to draw it so that it is easier to actually interpret it. And for what are we saying? Number one, you need to draw the decision tree from left to right, showing decisions and outcomes. Okay? Therefore, I would like to ask that we go to a textbook On the P1 textbook, I think it is test your understanding 9. Test your understanding 9. If we can go to our test our understanding 9 in our textbook, let's go to not test your understanding 9 but test your understanding 8. Okay, test your understanding 8. They're saying to you, calculate the maximum expected value of profit at decision point A. Therefore, now you are given the decision tree. As I said, the way you draw the decision tree, you'll move from left all the way to right. But the way you're going to interpret it, it will be from right all the way to left. Therefore, what is also important is to know what has been given to you in the textbook or in the diagram. Therefore, we're saying there are different symbols, as you can see on Test Your Understanding 8. Where you have a square is used to represent a decision point. At the decision point, the decision maker has a choice of which course of action he wished to undertake. Therefore, when they are saying to you, calculate the maximum expected value of profit at decision point A, because there's a square, it's a decision point. Sometimes you will have a circle. A circle is used at a chance outcome point. The branch from here are always subject to probabilities. Therefore, looking at Test Your Understanding 8, they're saying calculate the maximum expected. Therefore, if you are looking at that point now, you have two arms. At decision point A, we are saying this is your A. There are two possible ways in which you can go through. You can go through and invest. Alternatively, you can go the outsourcing route. Therefore, if you invest, or you can go through outsourcing. What happens if you invest? You will invest $20 million. And they're saying if you outsource, you're not going to spend any money. But if you outsource, you're going to make a profit of 10 million. But here we invest. And then we see a circle. What did we say a circle is? It's not a decision point. Whenever we see a circle, we said it is not a decision point. We said a circle is used at a chance outcome point, a chance outcome point. Okay? Therefore, if we invest the 20 million, there is a probability that we can have a high outcome or a low outcome. For further, we go this way: high or low outcome. And the probability of having a high outcome is 75%, and obviously 25% here. Therefore, if we have a high outcome, therefore our profit will be 50 million. But if we have a low outcome, our profit will be 8 million. Therefore, what we need now to decide on, Is it best to outsource or it is best to invest? At this particular point, if you outsource, you know you're going to make 10. It's easy. However, if, you invest, therefore there's a 50 million here, but the chance of making 50 million is 75%, and then you can make 8 million here, the chance of making that is 25%. Then minus what you will have invested. You want to calculate what will be the outcome. Therefore, that's what they are asking us. They're saying calculate the maximum expected. They didn't say calculate or tell us how much we're going to make. They're saying what is the maximum expected value. Therefore, in choosing the maximum expected value, you'll need now to be very careful. Okay? The first thing that you're going to look at is to say 50 million multiplied by 75%, that gives us how much? Is it 35? That is 37.5. Okay? You come, you're saying 50 million multiplied by 75%, that is 35, plus 8 million multiplied by 25, that is 2. Therefore, we're likely to make what? 35 plus 2, that is what? That is 37. However, there was an investment amount. Therefore, minus the 20 which we have invested. Therefore, we said 50 million multiplied by 75. Let's just recalculate that. That is 37.5. 37.5, okay? Plus 25% of 8 million, that's 2. Plus 2, 37.5 plus 2, that is 39.50, minus the 20. Therefore, we are likely to make here, how much? 19.50 million. Is it better than the 10 million? Yes, it is better than the 10 million. Therefore, here, we've calculated what? The 37.5 plus 2. That's what we have here, 39.5. Okay, then minus what we've invested, therefore we've made the maximum of 19.5. It's better than the 10 million. That's how we normally interpret. But I'd like to challenge all of you guys to go through your textbook, to look at the many examples, look at test your understanding 8 as well. It will test your understanding 8, test your understanding 9. They should actually help you to grasp this particular concept. Remember what I said. You're not going to be asked to draw in the exam, but you'll be asked to interpret. Okay, that's very important. If you have any problem with chapter 14, obviously chapter 14 for P1, but it's chapter 12 for P2, feel free to drop me an email or to call me. My email address is nkosinati, NKOSINATHIT @imas-sa.co.za, or you can send me a WhatsApp 083-698-5267. Feel free, anytime you can WhatsApp me, then I will call you back. This brings us to the end of this chapter 14 from P1 and chapter 12 from P2. I thank you.